We've spoken about epoxy-anhydride technology, and there's a lot of traditional uses for it, but I think what would be fun to talk about is how the traditional uses maintain that type of application, but are now moved into very modern instances. So let's talk, for example, about varnishes, wire enamels, things like that, that now go into, for example, the latest generation. Everybody's talking about electric vehicles, whether you're on board with that technology or not, it's here. And then obviously the next thing to come is the autonomous vehicle, which I don't know, I've got some concerns about, but that's okay. The increased demands utilizing the old traditional technology actually there's a really strong demand in those type of vehicles, which is a great opportunity for this type of technology.
Well, the technology still works, and there's nothing better to replace it with.
So that's what I mean. Yeah, new application, new thing, but you go back to the things that really work for it and work the best.
As we move from conventional fuels to electric and other alternative fuel vehicles, you see the increased use of motors drive-by-wire.
Just stop and think about how many motors
exactly
got to be in these vehicles, and not just for not even for the drivetrain, but for everything else too.
So that also requires encapsulation.
Yep.
And so I see a very good potential for use of epoxy anhydride systems in some of these applications, based on the traditional use of these materials in wires and wire enamels, etc.
Exactly. So you've got the motors, you've got the interior lighting. I mean, there's all kinds of unusual lighting now. You've got the telematics. Everybody wants a display everywhere to do everything for them. So this is the home where electric vehicles and certainly autonomous vehicles makes a lot of sense. So it's clearly opportunity for this application.
But then not only the electric vehicles, but also alternative fuels, storage of other gases, like hydrogen, for example, the need to have a system that contains that safely, efficiently.
So it's broad. I mean, it's across all these new technologies, right?
And hydrogen fuel cell, like Jeff, you
I mean, let's talk about that.
CNG tanks as well, so all kinds of options that you have available to alternative fuel-based vehicles. So these pressure vessels historically were made with steel. Which is heavy. Now in your car, it's all about fuel efficiency. You want to reduce the weight, so composite pressure vessels are the perfect solution to hold these gases as fuel. Again, these anhydride epoxy systems are very conducive because you can make traditional filament wound based processes. They are being used to make pressure vessels and very lightweight.
And yes, the carbon fiber overwrap pressure vessels, as they are called, they are extensively used in gas containment for both CNG and CHG. And as we move into the future, you're going to find more and more uses of these. I believe epoxy anhydride systems could play very well in this.
Absolutely.
It makes sense.
It makes sense.
It makes sense, especially, I mean, you're going to encounter a lot of extremes too. I mean, you're going to get one of these electric vehicles, you're going to drive it in all kinds of extremes.
What's the battery efficiency
5 feet with it? But same thing. Tremendous strains on all the electrical service in the vehicle. Tremendous strains on a pressure vessel.
Right.
I mean, you're going to see high temperatures. You're going to see low temperatures. So this is exactly the sweet spot. This is everything that we've been talking about.
Exactly.
Yeah.